Biofilm, a protective biofilm, which separates a polyanionic chemical composition is positioned on the exterior surface that reduces corrosion of the exterior surface. In one embodiment, the metal is aluminum alloy, copper, a copper alloy, titanium, a titanium alloy, nickel or a nickel alloy. In another embodiment, a metal or steel. In a preference embodiment, the steel is mild steel, mild steel 1010. Anti-corrosion protective coatings, anti-corrosion protective coating. Some coating types that are particularly useful on steel are inorganic zinc and epoxy. Inorganic zinc coating. Zinc coatings are extremely good for preventing rust on steel. They are also excellent for providing protection from environmental factors like salt water and harsh weather conditions. As a result, chemical plants and refineries often use such coatings to shield their equipment from deterioration. Additionally, zinc-rich primers can be coupled with super durable polyester coatings in a vast array of colors, resulting in a finish that is both highly corrosion resistant and aesthetically. Anodization is achieved by submerging aluminium in an acid bath and delivering an electric current throughout the environment. A cathode is incorporated inside the anodizing tank, and the aluminium in this setting serves as the anode. In this process, the oxygen ions are freed by the electrolyte to join the atoms of aluminium at the point that is anodizing. Therefore, anodizing is the process of extremely controlled oxidation of the enhancement of a natural or existing phenomenon. Galvanic corrosion, also called dissimilar metal corrosion or wrongly electrolysis, refers to corrosion damage induced when two dissimilar materials are coupled in a corrosive electrolyte. It occurs when two or more dissimilar metals are brought into electrical contact under water. When a galvanic couple forms, one of the metals in the couple becomes the anode and corrodes faster than it would all by itself, while other becomes cathode and corrodes slower than it would alone. Either both metal in the couple may or may not corrode by themselves when contact with a dissimilar metal is made. However, the self-corrosion rates will change. Corrosion of the anode will accelerate. Corrosion of the cathode will decelerate or even stop. Galvanic coupling is the foundation of many corrosion monitoring techniques. Use of inhibitors. Inhibitors are chemical substances used to reduce or eliminate corrosion. Inhibitors are used widely in the oil industry to prevent corrosion of steel by crude oils. Inhibitors based on chromates, phosphates, silicates, etc. are used to decrease corrosion of steel in aqueous media. Inhibitors have to be replenished at regular intervals in stagnant environments and added continuously to solutions that are in motion, such as a pipeline. Adding inhibitors to a solution does not normally prevent corrosion by its vapor. Use of cathodic protection. As mentioned earlier, cathodic protection is used to reduce or eliminate corrosion by electrically connecting a more active metal electrically connecting a more active metal electrically connecting a more active metal to the metal that must be protected. For example, zinc and magnesium anodes are used to protect steel in marine environments. Cathodic protection is also achieved with the utilization of an impressed current DC and using a relatively inert anode. An electrolyte is of course needed for purpose. Electron flow. Use of protective coatings. Inhibitive coatings. Inhibitive coating systems are based on a prime coat containing a pigment known to chemically react at the surface of the metal. Red lead primers are probably the oldest, followed by the chromates, polydates, lead suboxide, and barium metaborate. Many of these are losing their position in corrosion control due to the personal and environmental concerns being raised over the last decade. Inhibitive pigments release soluble ions into the water that penetrate the coating film. These ionic species are carried to the metal surface and increase the polarization of the anode or cathode. This process encourages the development of microscopic protective surface layers.